So we're going to take this detailed visual inspection and we're going to use tools to help us see things that maybe we can't access directly. You know, if we want to look inside of something, or if we need to look around a corner or behind a panel, that's where remote visual inspection comes into play. Okay. So there's three main types that we have that you'll see, referred to, and these are kind of official names, but what'll happen is what you'll notice is that these are oftentimes used interchangeably. Okay, but there are specific differences when we're talking a borescope or a fibroscope or a visioscope. There are kind of some dictionary definitions, but you'll often hear people refer to, I need to perform a videoscope. Well, if you're at any kind of a bigger organization right now, an MRO, an airline, that I guarantee, or they'll say, I need a borescope and engine. You're probably not going to use a borescope. You're probably going to use a videoscope. Okay, that's state-of-the-art technology right now is videoscope. But borescope is kind of the general term that's been around forever, and so you'll hear that. But what do they mean? So a borescope is by definition a rigid scope that we could put in. You've got some pictures there. This one that was on the page before is a very small borescope. Okay. Some bigger ones shown there. And what we have here is they're basically a tube, a rigid tube with a either lenses or prisms or mirrors, and in some cases fiber optics as well, but primarily mirrors, prisms, or lenses that relay an image from the tip of them, on these scopes, for instance, from the left end of them, to an eyepiece at the opposite end. And so that tip can be inserted into an area where we don't necessarily have easy access, directly, and then we can see or examine what's going on inside. I'm going to sit so I don't walk away from the microphone. Then the other part of that, though, is typically, if we're sticking a scope into an object, there's not going to be light inside of there. It's going to be dark inside of that object. And so they have the ability to somehow light up the space that you're looking in. And that's done either through a external light source, like a projector type bulb, that then light gets transmitted through fiber optic cable back out to the tip of the scope, or there's an LED or a bulb installed in the tip of the scope itself, with electrical wires running to it. And so it can light up inside of what we're looking at. Okay. To take that a step further, then kind of the next development in these things is a fibroscope. And so concept is the same. We're using some kind of an imaging device on the end, and then we're transmitting that image through, in this case now, a flexible scope rather than a rigid tube, to an eyepiece at the opposite end. And in order to do that, we need a flexible way to transmit. So prisms, mirrors, and lenses don't work anymore in that case because light isn't going to bend through the tube. So we need to run it through fiber optics. So there's a set of fiber optics, a fiber optic bundle running from the tip of one of these up to the operator end where there's an eyepiece. And again, just like our borescopes, we also need the ability to transmit light. And so again, there is either the most common is now these would have it has a second fiber optic bundle running through the flexible portion of the scope with an external light source that's going to project light into the area we're looking. Or again, they could use LEDs or a bulb in the very tip, what's called the distal end, to do it. The other thing you'll see here is this talks about a articulating distal end, and that is basic versions of these are just kind of a long, flexible kind of cable looking thing. But some of them have the ability where you can actually control the tip. You can make it, some of them are 2 directions, so they can bend up and down. Some of them are 4 directions. They can bend up, down, left, right, which lets you look kind of around in a cone shape pattern. So that's what you can see here at the very end of this one. Let me get my little highlighter out. At the very end, which is kind of sitting above right here, you can see this one has an articulating tip where that 90-degree bend that's kind of going on there is being controlled by the operator. Okay. And so that allows you to look around once you get into an area. And it also can be used to help guide it in. To take it a step further and look at what we currently would consider state of the art is now and what you're going to have at most of your more sizable facility that can afford the expense are going to have a video scope or video scope systems. And so now instead of using fiber optics to transmit, a light, basically the image of something directly to your eye, you have that flexible cable, that flexible housing with essentially a little camera, a digital camera at the very tip, digital video and still camera. And it's in the end of, again, you see that term distal end, that's the end of the scope that gets put into an object. That's the one that's sitting right here. Here's the tip of this. And this is an articulated, both these scopes right here have an articulating distal end. So it can be controlled with a little trigger on the control head. But they're going to have a CCD or CMOS chip. So CCD is known, it's a charge coupled device. It's a type of semiconductor that can pick up light. CMOS is complementary metal oxide semiconductor, another type of semiconductor that reacts to light. And that, it's the same type of thing that's in your camera, your digital camera, is going to sense light, pick it up. It's going to convert it into an electronic signal, send it through wires that are in the scope to some kind of a video screen. And so in this case, the scope on the left there, it's all kind of a handheld unit. You can see the little control, you grip it, it's kind of a pistol grip setup, and the screen's above it. And then the one on the right has a control head and then a separate screen there. And we have the scope we have to use in class is the one on the right there. That's a Canon, it's a Canon video scope. But there's different companies. The one on the left there is from a company called ViewTech. They're out of Traverse City, Michigan. But in this case, wires are transmitting the image. There's also wires running back up to the end. And most of these nowadays use an LED in the very tip. Some of the earliest ones used a bulb, but by the time these were coming out and becoming mass use, LEDs were available. And so most of them have an LED or multiple LEDs in the tip. And not only that, they can do some cool stuff with them now too, where rather than a standard visible camera, they can put an infrared camera in the tip of some of these with an infrared emitter or exciter. So when we talk about infrared thermography, you can actually perform borescope thermography, kind of combining. Or they can put an ultraviolet or a black light LEDs in the tip and be able to pick up, be able to go inside of objects where they're doing dye penetrant or magnetic particle or different type of leak check dyes and see the signature of those. So you can start to combine some of these, and they're pretty cool. So they're pretty high tech. The latest ones, we'll see a video. I've got a video that I'll have actually can do measurement and that kind of thing as well. And they're very precise. They can measure down to the 1,000th of an inch just using imaging. So pretty neat stuff that's come out with these. So those are kind of your 3 generations. We've got all 3 that you'll get to use in the lab. We need to understand kind of what they are. You've heard me use the term distal lens now a few times, or distal end. So here is a borescope, a very simple version of one, just with some of the different features. So again, the 2 ends, the distal end over here on the left is the kind of the tip of the borescope. That's what you're going to be, that's what's going to be inserted into whatever it is that you're going to be inspecting. Okay. The diopter is the end that you look at. So that's the eyepiece. So if you were using one of these, you would put your eye up to this right end. It would go right here. Here's your eyeball looking in. Okay. And some of the other features that they have, some of the other things you need to understand about these. 2 of the most important features are the working diameter right here. So that's essentially the thickness of the portion of the scope that gets put into an object, right? So some objects in like engines and other things are going to have access ports and holes and that kind of, and there may be a max size scope you can put in. But there's always obviously trade-offs. What do you think that was? So you can get skinnier scopes, you can get thicker scopes. What do you think some of the trade-offs might be? What are the advantages of a thinner scope, a smaller scope? You get in tighter places. What are the disadvantages? So, yep, they may be less quality, although you can get some really high quality video in a small scope, but what's the trade-off there? They're delicate. The small ones are delicate. Small area you're seeing. And then, but what if you want a high quality video in a very, very small scope? What do you think the trade-off is? They're going to be expensive. They're going to cost a lot more. So, you've got these trade-offs. What do you need to do the job? And what can you afford to, in some organizations, it might be what can you afford to do the job? There might be multiple scopes. Well, this one's got all kinds of bells and whistles. My wife and I are looking at cars. We went to drive a Lincoln yesterday for fun. Price they came back with was $90,000. And we said, yep, it's got a lot of cool, really neat stuff on it, but we're not going to use most of it. Nowhere near. It was just for fun. Quite a bit less than that. But same thing with scopes. You can get the very tiny scope with the super high resolution, with the measurement capability, and fully certified, and you're talking $80,000, right? Or you can go on Amazon and you can find, and it has the ability to like move, it's fully articulated, everything else. You can go on Amazon, just get a real basic scope, plugs into your smartphone for $100, right? But it's a thicker cable. It doesn't have articulation. Obviously doesn't have built-in video screens, that kind of thing. Maybe it's only a 640 by 480 resolution chip in the end of it, so it's up to what your needs are. So that's diameter. The other part of it is the working length right here. So that's the length where the diameter doesn't change. Okay, from the distal end, from the very tip. It's not necessarily from the lens. You can see there's actually the lens we'll talk about in a minute isn't right at the tip. But that's our working length. And again, there's trade-offs. A shorter scope. Why might you use a shorter scope? What's probably the advantage of one that's shorter? It's easier. Yeah, if you don't need a really long scope, it's less awkward, right? It's easier to maneuver. But if you need to get into a deeper area, think about like the JT9 you've worked on. Remember we had the spinner off and you could see down the shaft. Imagine if you need to see, you need to inspect the whole inside of that spool shaft, right? A 6-inch scope isn't going to do anything for you. So then you might need a 12-foot long video scope that can go the full length kind of thing. Okay. So different working diameters. Then there's the overall length of the scope. Length overall includes like the eyepiece and end. And then a few other things. So we've got our objective lens right here. This is going to be the primary lens where our image comes in or where the camera is located on a video scope. And that is the way you can remember that's out at the distal end. It's closest to the object that you're looking at. Okay. Objective lens near the object. Okay. The other one is you'll hear there's the diopter lens. There's a lens on the diopter end. And kind of the way, diopter, you can think of eye. It has eye in it. Diopter is near your eye. Okay, they contain eye. So those are the ways I can kind of the tricks for remembering which end of the scope is which. So the distal end with the objective lens is near the object, and the diopter is close to the eye. And then you got those. The last part of this, and probably the part that trips up students most, is the field of view and the angle of view. Okay. And so first off, we'll talk about the angle of view. So again, I'm going to put our eyeball back on here. Oh, I lost my pen. There it is. Here's my eyeball. Okay. So my eyeball is looking, in this case, to the left. You can see that center line of the scope. And here's my laser vision going down the middle, right? But in this case, the angle of view is which way am I looking compared to that line of sight. Okay, and in this case, you're looking straight up, right? The center line of this right here, you're looking straight up. So this has, you know, when you look out the end of the scope, I'm looking at it. In this case, it would be straight up, or if I rotate, you know, I can rotate the scope, I'd be looking straight left or straight right or straight down or wherever, right? But I'm looking 90, in this case, 90 degrees. So my angle of view here is 90 degrees. Okay, that's the angle of view, is the angle from the line of sight. Okay, the field of view is when I'm looking there, how wide of an area am I looking at? Okay, it's like blinders. You put your hands up on each side of your eyes. Go ahead and do this. Come on. You know, and you can have a narrow field of view, right? You can have a wide field of view. Okay, so different lenses are going to do that. You know, a wide field of view is like a fisheye lens. A narrow field of view is more like a telephoto type lens. What's the advantage or disadvantage to each of those? What's the advantage of a wide field of view where you can see way out to the sides? A lot of coverage. You know, you can see a lot all at once. What's the disadvantage to that? You're not gonna have too much detail. There is more to take in. You may miss something. There's another big thing. Anyone seen a fisheye lens, which is a real wide angle? You get distortion around the edges, and I'll show you some pictures. I'll show you what that starts to look like. Okay, so that's the big disadvantage. A wide angle of view lens, yeah, you can see a lot at once, but you get more distortion than you do in a small field of view lens. And that's the big difference. That's where we got to be careful when we're using these. And so again, you may select your scope based on, you know, how much distortion is okay, or how quickly do you need to be able to do the project, or how big of an area. So that's some of your vocab terms, I guess. Continuing on, here's kind of the scope used with the whole thing. So with a cutaway. So this is another, what kind of scope is this? Fluoroscope, video scope, fiber scope. It's a fiber scope. This is a borescope. It does have fibers in it, but what's the fiber used for? The light. So in this case, this is one of those, and actually this one, the previous one we had here, this is the thing down on the bottom there they show right here. This is where you hook up that external light source. Okay, so this one uses a fiber for that as well. They don't tell you on here whether it uses prisms, lenses, or prisms, lenses, or mirrors, but it could use any of those, but it's rigid. You know, it's basically a rigid scope. So here's another rigid scope. They show this one containing lenses down the length of the scope, right? And then it actually shows a prism at the end. What's that end called? Where the prism is? That's the distal end on the left. So you have, there's a prism that forms the objective lens down here on the distal end. You've got lenses here and here. Why do we need lenses? Why do you think you need lenses along the length of the scope? What are they going to do? They're going to focus the image back to your eye. Because remember, light wants to spread out, you know, it spreads out. And so if you just had that prism on the end, it would be really dim. You wouldn't get a good image by the time it gets back to the other end of the scope. You need to continually focus that light back together so it continues to travel down the length of the scope. And that can be done by lenses. It can be done by prisms. Okay. So the image, what we're looking at, you know, and here's our field of view. So what's the angle of view of this scope right here? What's our angle of view? 90 degrees. It's 90. You're looking, in this case, they're showing it straight up from the where your eye would be looking on the right side. And then the field of view, I don't know what the field of vision is there, 30 degrees or something like that. But you know, so the image, which is light, we're transmitting light in two directions here. The image is being transmitted by the prism and these glass fibers, you know, and it's going from here. Here's our object. and that image is being transmitted here. It turns 90 degrees, and it comes out here to our eyeball, okay, at the eyepiece. And then you can see that eyepiece is adjustable. That allows us to focus a little bit. It's like a focus ring, which makes up for where the object is compared to the end of the scope. It also can focus it because all of our eyes are a little bit different. And somebody that wear glasses, if you have a lighter prescription, you may be able to take your glasses off and actually focus the scope and get it to work. If you have a stronger prescription, you're probably going to have to leave your glasses on and focus that way. But if you have a fairly light prescription, you could always try using the scopes without glasses to see if they're able to dial in or your eye, and depending on what kind of, what you're correcting for and all that kind of thing. So that's one light path. And then our second light path is that one coming from the light source at the bottom. So here's our external light source that typically, like back in the day, these had like a projector bulb in them. Newer ones use like a halogen bulb or an LED. But then light travels up this, what they call light cable. It's a fiber optic cable, which runs along the bottom of the scope right here, glass fiber, and comes up to the end. And then it's going to project out from the tip of the scope to light the area we're looking at. Okay, it's going to have some kind of a little lens there. So that's we got the cutaway at the bottom, you got the whole thing at the top kind of showing how that is. So you can see where that cable comes in the bottom, that fiber optic light source plugs in the bottom, and then we look through the right-hand end. Okay. So that's still a borescope. The next then is, if we look at the internals of a fibroscope, it's built very much the same way, except now that image, the image now is being transmitted. You can see the arrows in the two fiber optics here. There's an upper one, and that's transmitting the image. The arrow's pointing to the left. And then down below, you've got the light source that's sending an image through the lower of the two fiber optics. So you've actually got two sets of fiber optic bundles here. One bringing the image from the tip back to the eyepiece, from the distal end, the objective lens, back to the diopter, the eyepiece. And then the other one going from the light source out to the distal end to be able to light wherever it is you're looking. Okay, this one also shows a control handle for articulation on top right here. So, and this one says it's four-way articulating. What that does is you're going to have little tiny like wires or flexible rods that run the length of the scope along with those fiber optics, and they're able to bend and pull that tip to make it move up and down. It's usually the last 2 to 3 inches of the tip that's able to articulate. If you're using an articulated scope, please be careful. Don't force it. You only want to bend it or move it using the control thing. Don't grab the tip of the scope and try to move it around. That can damage those very fine wires that are used to actually control it. In fact, our video scope, when you're doing the little controller, it's actually little motors. There's motors that move the little wires and everything. So they're very precise and they're very easily damaged. So, but you have all of that is running, in the case of our video scope, all of that's running through a thing that's about 3/16 of an inch diameter. It's flexible housing. But again, this works very similar concept. We're transmitting an image back to the eyepiece, and then we're transmitting light out to the tip. If we look at a cutaway of a video scope, now this is just kind of the tip end of it. We all know what we take a video camera and plug it into a TV. That's basically what you got at the control end. But the internals of a video scope look something like this. And so here, you've got, this one shows those articulation cables. They show those here, those 4 articulation cables right here, and then the fiber optic bundles. You can see the construction of these things is almost like a hydraulic hose, and that you got multiple layers. You got like braided layers of metal and rubber, and so they seal them. So hopefully you don't get contamination inside them, oil and grease and other stuff. And then out at the end, you have a camera with an aperture at the very tip, the camera head right here. And that camera coming through the middle is going to then be surrounded by or it's going to have next to it or be surrounded by one or more LED lights. So there's what the tip of one of these things looks like. You can see in all three cases, the cameras, that circular, has that little teeny tiny circular lens in the middle. And then you've got lights around the outside of it. And then these are, there's that shows that tip that's able to articulate, how they can be bent up, down, left, right. Now, when you're using these, what's kind of neat is oftentimes you need to get into an area further, but you know, it's kind of like trying to see how far you can stretch out a tape measure, right? Eventually the fiber scope's gonna flop down, or the video scope's gonna flop down. How do you think we can get into an area that's like further back? If that's the case, what might you do? Feed it through a tube. You get a piece of hydraulic tubing and you slide your scope through it and basically turn it into like a borescope, into a rigid scope, you know, and use that tube. In fact, if you'd get like Pratt & Whitney, GE, for certain inspections, they actually sell kits of all these like pre-bent tubes, where maybe you put the tube into a, you know, where a fuel nozzle goes, and it's basically the same shape as a fuel nozzle, and then you can feed your scope into it, and it routes your scope down into the combustion chamber, you know, or, you know, any number of other ones that are designed to route the tip of the scope to the correct spot where you can see what it is you're looking at. So, okay. So those are different types and kind of the lighting and the configuration. We'll leave off there, and when we come back, I've got a video that'll show, and then we'll move into kind of the actual process of performing remote visual inspection. So go ahead and take a break.